Thank you, Andras, for this introduction. So I will speak about new tools and new concepts that we put in place at Renault during the development of the vehicle. And the objective of my talk is to introduce from what we call digital vehicle, virtual twin, and immersive virtual twin. Immersive is an important topic because immersive means that you put the driver or the customer in the loop of the simulations. So, as you are a good engineer in system engineering, I will discuss in 3 points my talk. The first point will be why, the second what, and the third point will be how. So for the first point, why? So there are some elements that you have to take in considerations. Why do we put this digital vehicle and immersive virtual twin? First, because you have complexity of systems. And what is important is automotive is facing not one disruption, but 4 disruptions. And also, another one is also the lead time reductions. So today, we are switching little by little from 3 years for the development phase of a vehicle to 2 years. And in terms of mobility, what is important is we spoke of ADAS, but the business is not only ADAS. The tomorrow mobility will be based on electricity, electric cars, connected car, shared cars, and automated cars. So you see that with all these domains, you have to face what we call system of system, and validations will be more and more difficult. Just to illustrate what is complexity, I take the example of what we call software-defined vehicle. So you have to face very important difficulties. The first one is business model is changing. So you have more and more new applications that you have to integrate. You have also difficulties in terms of electronic or design or architecture, because more and more you are switching from ordinary normal design to IT design, because you are integrating car OS, for example Android, you are integrating Ethernet in the car, you are integrating new components, so the hardware will become very, very complex. You have also to face new business because you have service on architecture, so you have to face that after the start of production of the car, you have to be able to integrate new applications, and you have also to integrate validations. Yesterday we spoke of IA, and you have to face that when you will change the data, you will have to redo all the validation cycle, and of course homologations leading. You have to integrate safety and security, and in particular to validate that your car is compliant with cybersecurity, and you have many activities to validate that. And finally, you have also to manage change in your organizations, because to be able to do that, you have to shift left the validations, meaning that you have to now to work with model-based, and of course, all the validation and simulations associated. Another topic that you have to face with is also regulations and homologations, because you have more and more, for example, for ADAS, you have more and more ADAS that you have to test. You have also more and more scenarios. We are speaking of GSR2, and now GSR2 is an amount increase of number of scenarios that you have to test and to prove to the homologations. And you have also to increase of scenarios and dangerous situations. And to do that, it's very difficult to do it using real cars. So today's homologations is changing little by little. You have many initiatives that were launched, but they agreed that on 2 topics, 2 pillars, that you have simulations and scenarios that you have to create. And the way is ongoing now, because credibility assessment has been agreed, And you have now an amendment for example, for ABS, to be able to do some validation for homologation using simulations. So you see that regarding homologation, complexity and demand of simulation is increasing. For the second topic is what? So we have explained the context. Now we will explain what we want to do. So what is important is that when you have to validate, validation using simulations can start before reaching the bottom of the V-cycles. You have to put your simulations during all the design, and you have high-level test plans can be arranged at any steps. So in that diagram, it's not, you have not to read it, but you have on the vertical axis, you have the different layers in terms of system engineering. So you have the vehicle layer, intersystem, systems, and components. So for all these layers, you have requirements. On the arrows, you have different means that you have to do during the development. At the beginning, you are working with functional models, and then more and more you are integrated real applications, so software in the loop, and at the end, vehicle in the loop. And what is important when you make simulations is that you have to fulfill all these black bullets. And all these black bullets, you have to do it continuously during the development of the vehicle. So what is important also is that you have to create continuity with your tools, because if you change from model in the loop to software in the loop, you have to use the same environment in the simulations to be able to switch from functional to software in the loop simulations. And what is important is model-based system engineering is mandatory for managing continuity and traceability. Just to have an overview of what are the activities that you have to do, we have to create baseline, and baseline is to create models. And to create models, as you make synthesis simulations, you need to use standards. So what we use is FMU standards, because it helps you to make simulations using physical modelizations, but also software modelizations. You have to create scenarios, and there is big initiatives regarding scenarios, and you have to create terrain. Based on that, you have to create your simulations platform, and your simulations platform is based on 3 topics. The first one is create the digital vehicle, create driver models, and integrated the environments. As soon as you have integrated everything together, you need to be able to play these environments on different assets for simulations. And as I explained, these simulation assets needs to be continuously linked. Because when you have a validation plan, you have to define what you want to validate, and depending on what you want to validate, you can address different systems for simulations. And for that, we use a virtual reality platform, you use a driver in the loop platform, integrated electronic platform, or cloud computing platform. And all that, again, needs to be managed by PLM, meaning that you need to be traceable and manage configuration. How do we do that? We have to create the platform, the simulation platform. A simulations platform starts from what you want to do, so the requirements, and what you want to test, the results. The simulations platform is done on 3 pillars. The first pillar is to create the digital vehicle, as I explained. And this digital vehicle is based on compiling different FMU regarding a definition or configuration that you have in the PLM. The second topic that we have to do is to simulate the driver. So you have 2 types. Either the driver is a real driver in immersive simulations. That's nice. either the driver is simulated. If you want to go to a cloud computing simulations, then you have model-based driver. So you need to adapt the driver, to modelize the driver, and of course, the driver is related to the scenario and the dynamic of the car that he is driving. The third topic is environment simulations. You have to create terrain, you have to create scenarios. And again, as I explained yesterday, some database of the scenario could be at a scene and so on. So it's something that could be managed and shared with all the stakeholders. And as soon as you have created this simulations platform, you have to run the simulation platform, and this simulations platform can be run on simulation, driver in the loops or simulation, driving simulator, sorry, XR simulations or cloud computing. And all that needs to be linked to requirements because the requirements, of course, has an effect on the simulations platform. Depending on the requirements, you define which simulations platform you want to use. Just to explain how we manage the continuity. So as Thomas explained, Scanner is for us important as an orchestrator, but Scanner is not doing everything. It is linked to different environments, and we use a Scanner to drive massive simulations, meaning that we launch millions of kilometers, millions of use cases on cloud computing. So now we are switching little by little to Google Cloud. We can use also, in some cases, driving simulators. So we can extract some scenarios from the massive simulations and replay this scenario using a driver in the loop simulator. We can use the same environments with hardware in the loop, of course. In that case, we disconnect the model of the ECU and we replace it by real ECUs. But it's the same simulation environment. So what is important is this interoperability and continuity. We can use it in vehicle in the loop, putting the driver in the loop, but with a real car. And finally, we can use it in virtual reality environment because it's very important also to address acceptability and this stuff like that around HMI, for example. Just to illustrate what we do in immersive. 3 topics. The first one is to use our road driving simulator. So road, which is a Renault Operational Advanced Driving Simulator, is linked, of course, to scenario, to drive a digital vehicle, and we put the driver in the scene. So can you launch the video, please? Okay, just to illustrate what we are doing. So road is our dynamic simulator in Paris. So you see on the scene, it's what our test driver use. It's a test track that they are used to do it. And what they are doing now, for example, in roads, they are testing new tires, new chassis, and new design of the chassis. So it's very useful in very early stages in the development phase. And we are able to reach 1G acceleration, and the latency is 30 milliseconds. So they can drift, they can check what is the behavior. So you see. So the difficulty for this type of simulator is motion control, of course, because it's order 1 to create immersivity. The second type of immersive simulation that we use is what we call vehicle in the loop. So vehicle in the loop is I should say, augmented reality for a driving simulator. It means that you have in the back of the car the same scenario that you use for massive simulations or for the driving simulator. And this scenario is connected to a real car. So we inject on the architecture, the electronic architecture informations, but the car is a real car with a real driver. So the real driver has the impressions has the feeling that he is on a car, on a track, but there is no car. So you see on the right side, you have for LSS, oncoming traffic. So it's quite dangerous to do it with real time, even if it's a mock-up. But you drive very close to the mock-up, about 30 centimeters. And on the screen just above, you have the same situations, but the driver drive it on an open road with no cars. The car is only a car simulated. Of course, the driver has the feedback of the scenario on the screen. So that's another topic, and it's very useful for people in charge of fine-tuning of, let's say, ADAS system. And the last topic is what we call in immersive virtual twin. So when you use virtual reality, you have a paradigm. You are in a virtual world, but you want physics. You want to touch something to create immersions. So what we are doing now is we integrate 3D modeling. So we use the digital mock-up and we animate the digital mock-up. So for example, we use Unreal to do it. We use physical part to create reality, because you need to touch something, you need to have border if you want to enter the vehicle. So it's not a prototype, it's just parts of wood, but very simple. But we also add functional models, because sometimes you want to test HMI, you want to test new assets, so you have the functional model. So if you look at that, you have the reconciliations of two worlds, the 0D worlds plus the 3D worlds. And with this digital platform, we simulate user experience, converge functional requirements, and make the synthesis for the project. Can you launch the video, please? So you will see an example of what we did on the Rafale. So you have on the right, you have a seat. You have a user with a headset, and the user is entering the car. So you see on the left side what he is doing. So you animate 3D parts. We are able to touch the screen. So when he touched the screen, the 0D model of the HMI is acting. And at the end, if you want to touch another button, a virtual button, we have a robot putting this virtual button at the right place according to the architecture of the vehicle. And he can press this button, and for that, on the Rafale, it was for the solar bay, and we can animate it. So just an example of what we are doing, combining 0D, 3D, and physical parts. Just to finish, some ongoing challenges, because all that is not possible, is only possible with some enablers. The first one is to manage configuration. I explained that model-based system engineering is mandatory if you want to have traceability and continuity. You have to manage interoperability and continuity of the tools, because you have to switch from one means to other means, and it has to be continuous. Third thing is to manage simulations models, and for that you have to use standard, Open Drive, Open Scenario, FMU, and so on. And the last one is important also for homologations. You have to manage correlations. Correlations is very important because homologations needs to be correlated. Assessment tools needs to be correlated. So you have at a certain point to switch from digital vehicle to virtual twin. because this virtual twin, as I explained, is a new business, will have to continue to work and to be used after start of productions, because when we will change applications of software, you will have to redo all the validation process.